So the first open question in science is, what's the universe made of? So that's the first open question.
Easy one, right?
Yeah,
Okay.
let's
Easy
start with
one.
the easiest.
Yeah, now you would say we know what the universe is made of: atoms, molecules, force fields, gravity, electromagnetism, all the things that science talks about.
Unicorns.
Yes, maybe. Here's the dilemma: 70% of the universe is a mysterious force called dark energy. And we have no idea what it is. Einstein described it as the cosmological constant. And then he said, oh, it's one of my biggest blunders. But actually, he was right on, as usual. You know, Einstein used to doubt his own theories, and then they turned out to be right. For example, in 1935, he spoke about entanglement. Then he said, no, it's not possible. Spooky action at a distance. He ridiculed his own findings, but he was right. So 70% is this thing that we have no idea. It's the opposite of gravity. And the universe right now, as we sit here, is expanding faster than the speed of light, which is again a violation.
Can you talk us through the opposite of gravity?
Yeah, so gravity brings things together. And this force expands things. So it's the opposite. So right now, as we are sitting here, the universe, the space between galaxies, is expanding faster than the speed of light. So the cosmic horizon, which is from here, where we are sitting, is about 50 billion light years away from us. And galaxies are tumbling across that into the unknowable. Okay, because by the time light gets from there to here, our solar system won't exist. It will have burnt itself up into the heat death of absolute zero. That's 70% of the universe, which we don't know. Whatever this force is, it's not atomic, and you and I are made of atoms. So that leaves 30% of the universe that is remaining. Of that, 27% is another mysterious energy called mysterious entity called dark matter. So dark matter is invisible. This matter, this table, my body, it's visible. And the reason it's visible is made of atoms. We are made of atoms. Dark matter doesn't reflect light, absorb light, emit light, or whatever. So we don't know what it is. So why do we call it matter? Because it's responsible for most of the gravity in the universe. If you didn't have dark matter, planets would spiral off and get lost in intergalactic space, and you and I wouldn't be there.
I mean, it's been a minute since I've studied physics. How do we know it's there?
We actually only surmise it's there by its gravitational effects.
Got it.
And right now, there are a lot of places in the world that are looking for it through technologies under the ground, and they have a hypothetical entity to describe molecules. It's called a WIMP, weakly interactive massive particles. Okay, but nobody's seen a WIMP. Now you have 3% remaining, which is atomic. Of that, 99.999% is invisible interstellar dust, probably hydrogen and helium, which was created at the Big Bang, according to current scientific models. So the visible universe, which is 2 trillion galaxies.
What we're interacting with, in theory.
Yeah. The visible universe, 2 trillion galaxies, 700 sextillion stars, and according to the James Webb Telescope right now, probably 60 billion habitable planets in the Milky Way galaxy. Multiply that by 2 trillion galaxies, you have habitable planets. The whole universe is teeming with life as we know life. So if a planet is very close to its sun, too hot, too far, too cold, no life. But then there have to be other things like the right amount of gravitational, electromagnetic constants. That visible universe is 0.01%. The rest is unknown or unknowable. Unknowable because if it's not atomic, how do you know what it is? You can't interact with it. Now, here's the problem.